Hi everyone. Today here is we are going to start to give application of limits. That's what I gave you last chapter about limits to when x close to c, a specific number, finite number, or x close to infinity, or x close to minus infinity. So here today we are going to give average rate of change. In our applications, real life situation, we have a change quantity. The quantities keep changing, and we would like to know how fast. That is what we like to know, how fast if it's change, like how fast the change will be, or how to measure the change. So now if you have a straight line, if for example here, if you have equation of a line, what is the equation of any line? Mx plus little b, right? Mx plus little b. What is your m here, guys? Your m here is, we call it the slope, right? It's the slope from high school. And also b here, what is y? B, y-intercept. Your b here is y-intercept, right? Y-intercept. So now I need to, for example here, if you have y equal, say, 2x plus 1. So now if I make a table here, guys, if I make a table here, that is your x and that is my y. If your x say 1, and here 2, and here 3, and here 4, right? So what is your y? When x equal 1, what is your y? Just replace x by 1. So what is your y? When x equal 1, your y is 2, replace x by 1 plus 1 here. So what did you get? You get 3. When x equal 2, what is your y? Your y here is 2 plus 1, which is just 5. So I write here 3 and 5. When x equals 3, just replace x by 3. What did you get? 2 multiplied by 3, 6 plus 1, 7. If x equal 4, so 2 multiplied by 4, you have 8 plus 1, you have 9. So now I want from you to note something here, guys. When x increase by 1 unit from here to there, what is your x? Increase from here to there, how many units? 1. From 2 to 3, what is your x increase? 1. From 3 to 4, it's 1. What about y? From here to there, your y increase by 3. Your y increase by 3, right? So, sorry, your y increase by 2. 3 to 5 is just 2. From 5 to 7, 2. From 7 to 9, just 2. So here, when x, let me write it, when x increases by 1 unit, what happened for your y? Your y is going to increase by how many unit? 2 unit. How did I get 2 unit? That is our slope, 2x. So the number in front of x here, that is called slope. That's kind of measure the change of your y. When x increase by 1 unit, your y, even without this table, as soon as I look to the slope, which is positive 2, then your y is going to increase by 2 unit. But your y increase by 2 unit, right? So if I repeat the same example here, but I have y equal negative 2x plus 1, then your slope is what? Your slope here is negative 2. If your slope is negative 2, means your x, when x increase by 1 unit, all right, your x increase by 1 unit, what happened for your y? Your y, it will be decrease. Your y is decrease, going down by how many unit? Whatever the slope here is negative 2, so which means 2 unit. So the negative sign here means it's decreasing, going down, decrease. If it's positive, it will be increase. But your x here, your x keep increasing by 1 unit, but your y is going to decrease, going down by how many unit? 2 unit. So your slope, if you have a line, equation of any line, and remember that is equation of a line, and also we could call it linear function, f of x. Your y, I can call it f of x equal mx plus little b. So that is linear function or equation of a line. So your slope here, your m, is going to measure the change of your y or the change of your f. A change your y or a change in your f, right? So now, if you recall this one here, guys, what we have for Math 1070 here, if you have a cost functions, if you recall as a business here, cost function, c of x equal mx plus little b. What is your m here? That is our slope, but we call it here, sometimes we call it marginal. If you recall, marginal, or sometimes we call it variable cost. Variable, that is from as a business 1070, so variable cost, right? And your B, we call it fixed cost. That is your y-intercept, fixed cost, right? So the question here is now, and I know if you have a linear or equation of a line or linear function, our life becomes very easy because you are looking for the change, look to the slope, and that is going to measure for us what the change in your C, the function C, the cost, or your Y, or your F. But what happens if you go for nonlinear? If I go for nonlinear, what is the simplest nonlinear model that you have? If I go for nonlinear functions, nonlinear, there's no nonlinear function or nonlinear models here. It's models. So the simplest nonlinear models you could have f of x, quadratic ones, quadratic ax squared plus bx plus c. It is one nonlinear, yes, that's the simplest one. So here nonlinear could be quadratic, it could be exponential, it could be log, it could be fraction, it could be anything. So it's not linear anymore, no longer linear, which is no longer in this form. So the question here is how to measure the change of your f. For example, here, if I give you f of x here, that is what I'm going to give you as a graph here. So let me give you a graph here, a graph like this. That is your x here, and that is your y, or that is your f. If I give you a graph like this, guys, okay, I give you a graph like this, all right? So this one here, the graph of your f, yes, that is my f, that is your x-axis, that is your y. Remember your y here equal f of x, right? It's a functions. So now, what happened, I need to measure the change of your f. It's not linear anymore. When I have a linear, just try to show you here, equation of any line, if I up here, when I give you a line here, this one, that is equation of a line. So what is equation of the line means here? Just to try to show you the difference here. If you have a line like this, if you take any 2 point on the line, any 2 point here, that's 2 point on the line, or you can maybe take another 2 point here, any 2 point you can take it as you like on the line. And then what is the slope? The slope here, if you recall, the slope is what? The change in y, if that is your x1, and this one here, it's y1. That is your x2, and that is your y2, right? So this point here is x1, y1. This point here, x2, y2. x2, y2. Or what is x1 and y1? You can take this one, you can call it x1, y1. You can call this one x2, y2. So any point take any 2 point on the line, whatever you wish. So how to get the slope? We call it the change in y over the change in x, or y2 minus y1 over x2 minus x1. That is give you the slope, y2 minus y1 over x2 minus x1. y2 here is, if that is linear functions, like your y equal f of x, which is mx plus little b. So what is your y2? y2 here, it will be your f2, f at x, f2 minus f1 over x2 minus x1. f2 here means, just to try to, f2 means your f at x2, and what is your f1? f1 here is your f at x1. So that is your slope, guys. That is our slope if you have a linear. So now our goal here is to go for nonlinear. That is nonlinear. That is non-linear function. There's no linear anymore. So now what's the meaning of nonlinear? Nonlinear means if I take a point here, those 2 points, say for example this one, I call it A, this one I call it B, right? Let me call Q here, that is your Q at a point, and that is your P. So now what is your A here? What is your y-axis? That is your f of A. So this point is A, f of A, f of A, and this point is B, f of B, B, f of B. What is your y? If you take axis here, it will be the value of f at B, the value of f at B, and that is the value of f at A. So you have 2 point P equal A, f of A, that is your x, y. Your B here, B, f of B, that is your x2, y2, x2, y2. If I take any 2 point on the graph of your f, now if I connect them here, what happened here? If I connect them here, so there is a line between P and Q. That's called line segment, or a piece of line connecting P and Q. Now, if you try to say, oh, can I take the slope of I have 2 point A f of A, B f of B. So if I go down a little bit here, I try to apply that. So you have your P. What is your B? A f of A, right? What is your Q? Your Q here is B f of B, right? That's 2 point. So how to get the slope, guys? The slope here is, it will be the change in your f over a change in your x. So that is, it will be the change in f, right? A change in f over a change in your x, right? So what you are going to do is say, okay, what is the change in your f? It will be f of b minus f of a, right? F of b minus f of a over divided by b minus a, b minus a, b minus a. So what does this give you, guys? What does give us here? Give you the slope between the line connecting between P and Q. The line connecting between B and Q, that is your slope. So it does not give us the slope of your f. Does not give us the slope of your f. Now I'm narrow myself to A and B. Look what you have, A and B. So here is your graph. I'm taking point A on the graph, B here. So I'm going to, this one is going to give, we call it here the slope of the line segment between A and B, but also we will call it here, I don't know what happened here, this looks here, there is my hand hit the keyboard. So that is this one here, that gives you the slope, right? But also we are going to call it the average rate of change, the average rate of change, the average rate of your f of x, of change of your f of x. So the average rate of the change here of your f of x, here over a specific interval A to B. Look what you have here, A to B. A to B here is what? A to B here from the graph, I'm just taking a point here, A and B. So A and B here, the interval that is start from here, that start at A, and B here, that's kind of over the interval. So if you take another 2 point on the graph of your f of x, your average rate of change is going to change. So what is the difference between line and linear and non-linear? This one, it's a linear, means if you take any 2 point on the line and you get the slope, you'll find the slope is the same. But for non-linear, if you take any 2 point on the graph, that's non-linear, any 2 point, if you look to the change in your f over the change in your x, every time is going to change. Every time is going to change, because it does not give you the slope of your f, because that's a non-linear one, but they give you the slope of the line connecting between P and Q. Give you the slope of the line connecting B and Q, but that does not give you the slope of your f. So here we are going to show you how to get the slope today, how to get the slope of nonlinear functions. But here, so here, as you can see, if the rate of the change is a straight line, a linear function, then the slope is going to measure the rate of the change. But what happened for nonlinear functions, as I mentioned, what happened for my nonlinear function, if you take any 2 point on the graph, it's going to give you the average rate of change of your f over a specific interval, which is the 2 point that you take on the graph. But if you change the 2 point, then the average rate of change is going to change. And here, that is the answer here for number 3. If you take any 2 point on nonlinear graph, then it's going to get average rate of a change, and this one is going to change. Now I'm going to show you later here how to get the slope in order to measure the change. But now let us give some example here. Here is the formula here. This formula here I'm going to use as a measure the change of your f over the change of my x here. Change of your f over the change of your x, that is give you the average rate of change. Let me give you some example here. So I have some example how to get the average rate of change, and then I try to show you how to get the slope here. So for one example here, if I give you f of x, what is your f of x? Your f of x equal, say 2x squared plus 4. And they give you the interval here, -1 and 2. So what is the question here? I need to find the average rate of change of your f of x, the average rate of change of your f of x, all right? Of f of x here is given, over the interval here is -1 and 2, right? Where is the formula here? What is my first? What is your A and B? Oh, your A and B here is, your A is what? -1. What is your B? 2. So here, your A, just right here, it is -1. What is my B? My B here is 2. So what is the average rate of change? The average rate of change, I'm writing in short, that's called the average rate of change of your f of x over the interval. Just I have to copy this here. And then it will be f of B, right, minus f of A, the change of your f over the change of your x, which is B minus A. So what is your B, guys? Your B here is 2. What is your A? -1, so minus, look what you have. I'm very careful. If you have a negative number, always put it between bracket. Your f of B, it will be, what is your B? F of 2 minus f of A. What is your f of A? -1. Your A, -1, right? Your f of A, -1. So now I need to get the value of f of 2, and also I need to get the value of f of -1. So what is your f of x given here, guys? Oh, f of x, your f of x given by 2x squared plus 4. 2x. So what is your f? Go ahead and find f of 2. Just replace x by 2. If I replace x by 2, what did you get? You get, replace x by 2, you get 2 squared plus 4. If I simplify, so 4 multiplied by 2, you have 8 plus 4, you get 12. You get 12. Is that correct? Yes. So now, if what is f at -1? F, I need to get f of -1. Again, you just go ahead and replace x by -1. So you get 2. You get 2, and here -1 is square plus 4. If I simplify this, you get 2 plus 4, which is just 6. So what is your average rate of change? Your average rate of change, f of 2 is 12 minus 6. And here, negative times negative. What is negative times negative? You get positive. So you get here 6 over 3. What did you get? You get 2. You get 2. So now you get 2. That is our average rate of change. And here there is a unit. Your f here, it could be cost functions. It could be cost. It could be profit. It could be revenue. It could be supply, and so on. So what is the unit of your f? Your f here, if it's a cost function, then the unit should be in dollars. The cost here, I'm talking about money here. So the cost there, it will be dollars. B minus A here, X here, it will be number of item or unit or product. So if it's here $2 per item, it could be product here or item. That is your X, number of item or number of product, right? Your cost here, when I say you have a cost functions, C of X, look what you have. Where is the cost function here that here in this formula here? This one. Your X here, number of item or product, could be t-shirt, it could be tables, could be any product or item. What is C? Cost. So that is a cost function. So here, because the change in your F over a change in your X here, so the unit of your F, it will be dollars per whatever you have X here, per item or product or t-shirt or whatever it is. That's called unit of your average rate of change. All right. So that is one example here. I give you another example here. What is another example I give? I'm going to give you. You could have a table, guys. You could have a table, and this table here is given. So here, that is your X, and that is what else you have. So in the table here, I'm going to give you another example here. That is year. It's called year, and that is called here net sales. Net sales. So that is this table is given in 1990. Then 1990, what do you have? You have 700. That is 700. All right. And in 1991, what do you have? You will have 810. 1992, what do you have? You have $980. And then I keep continue here, 1993, right? And 1994, right? So 1993, you have 990, and then you have 980. All right. So what is the problem here? You have a net sales here. So that is a problem, net sales, right, of some company. Say this company is called Lotus Development, right? So just, it's a company, right? And that is the table here. That is the net sale of this, of the company. What is the question here? The question here is, they ask you during, they tell you here, during which, that is what the question here, during which 2 years, right, interval, 2 years interval, you have 2 years interval was the average, all right, was the average. I'm just writing here the average, all right, the average rate of change of annual net sale, all right, net sales, right. You have greatest, the maximum here, the greatest and the smallest, so what you have smallest, and B you have the greatest, all right, smallest here, and B you have the greatest, all right. That is very easy here. Why? Look what you have, the table is given here. So now what is your F? What is my F? What is your X? So your year here, that is a time, that is your X. Net sale, that is your function, your F. What is the average rate of change here? The average rate of change of f of x over interval a to b. Look what you have up here, over the interval a to b. F of b minus f of a over b minus a. What is your a and b? That's the time, year, in our example year. What is your f? That is your net sales. So here, if I go, what is the average rate here? It will be net sale. That is my function, the average rate. So the average rate of change, I have to take over, that is a net sale in 1991 minus the average, the net sale at 1990 over the change that over. So this, the average rate over the interval 1991 and to 1990, that is the interval. It will be 1991 over 1990. So now, what is the value for your net sale at 1991? You have to go back to the table. 1991, you have 810 here. That is a function. At 1991, you have 810. So I go back here. You have 810 minus 1990, which is 700. So you have 700. Then you have 1991 minus 1990, so you get 1. So what did you get here, guys? You get here 810 minus 700, you get 110. That is per year, right? Look what you have, the unit here I'm talking about. Net sale here is the dollars per year divided by years. So that is up here, the net sale is in dollars per year, right? You keep continue here to compute the average rate of change in 1991, right? Between 1991 and 1992, you keep continue here, all of them here. So 1992, right? 1992 minus 1991. What is up here? It will be N 1992 minus 1991. So the difference here 1, but what is the value of the net sale at 1992 from the table? Oh, 980 minus 1991, the net sale is 810, so it just takes the difference. So you have 980 minus the difference, I forget, 1990, 810, just 810. Thank you, 810. So here, if I say 810, just what's the difference here, guys? 810 here, so the difference, so you get 170 per year, right? Then I have to continue 1992 to 1993, right? So what is the average of this? You go up here from the table, 1993, so you get 990 minus 980, and here 1993 minus 1992, you get 1 down, so you get here 990 minus 980, right, over 1993 minus 1992. So what did you get? You get just 10 per year. What is the last one? 1993, and over this interval 1994. What is the difference from the table up? Go up here. Oh, you have 980. That is 980 here. 980 minus 990. So here you have 980 minus 990 over 1994 minus 1993. So what did you get? You get minus 10. So what did you get? The smallest value here, that is the smallest value over this interval 1993 1994. That is where the smallest value could have for the net sale, minus 10, right? And what is the largest or the biggest one? That's 170. That is the greatest or the maximum for the net sale per year. So over 1991, to 1992. That over this interval, you have a big net sale. That is the maximum you could have for the net sale for the company, and the smallest one in 1993 to 1994. So here, the average rate of change, I try to tell you, in the first example, I give you f of x as a function. Look what you have for this example here. You have 2x squared plus 4. That is given. But here, for example number 2, is not given f of x, but they give you the table. So table means you're here, 1993, the value of your f. What is your f? Net sale, 700. So from the table, I can compute the change of your net sale over the interval here to compute the average rate of change, right? So that is very much you could have. And another example here, I could give you f, not a table, but I could give you a graph here. So what is a graph is given? Look what you have. If I give you a graph like this, all right, a graph like this, and then what do you have for this one here? So maybe I write here 1, right, and then I give you here 4, and then this one here you will have 1, and this one you have 2. All right, so here is the graph. F of x is given, and that is your y-axis, which is your f, and that is my x. Right? So a graph is given to you, and then what is the question? They ask you to compute the average rate of change, of your f of x. F of x is not given, just a graph is given. But it's very clear this graph is what? Is x squared, right? Parabola here, x squared, f of x, over, they give you the interval, which is 1, 2. You just try to by graph. So now, what is your average rate of change? It will be f of 2 minus f of 1 over 2 minus 1. So f of 2 here, I have to make vertical line, and then to see what is the corresponding value. What is the value of f of 1? F of 1 here from the graph is 1. F of 2, I make vertical line. Then what is the value here? It will be 4. So f of 2 from the graph is 4, right? So it will be 4. F of 1 just 1, and here 2 minus 1. So what did you get? You get 3 divided by 1. So that is our average rate of change. So we could give you a graph like this, and from the graph you need to figure out the average rate of change of your f over a specific interval. Here is 1, 2. Or they may give you a table like this, and they ask what is the average rate of change, or they may give you f of x explicit like this example, 2x squared plus 4, right? So that is, the whole thing here is called average rate of change. So now I'm going to give you another, maybe I have to recall or define for you something called tangent line. What is the tangent line? Tangent line, that is a line touch the curve, touch the graph, right? The graph at most 1 point, I'm going to give you at most 1 point. So that is called tangent line. What is the tangent line? For example, here I give you a graph. If I have a graph like this, and then that is your x and y, that is your x and that is my y. The tangent line, it's a line touch the graph at most 1 point. So a straight line, I should have a straight line, right? So maybe that is a graph here. Then I have to make a line, this line here, that is our, we call it tangent line. It's a line. So equation of a line, which is mx plus b. But what is the specific this line? The line touch only the graph at most 1 point. So if I have a circle like this, the tangent line here, it's a line touch the circle here at most 1 point. So here, touch the circle at 1 point. If the line here touch the graph at more than 1 point, is not tangent line. So the tangent line means it's a line touch the graph at most 1 point. That's called tangent line. All right. So now, what is your goal? I need to goal to get the slope of here. I know if you have a linear functions or linear equations, we know how to get this. We know the slope here to measure how fast the change of your f. So now, how we are going to get the slope for nonlinear? You are asking a questions how to get the slope for nonlinear. So for the example that I gave you for your f of x up, that is your x and that is my y. I said take 2 point here. That is your P, right? And that is your Q. Remember, I take 2 point, and then what happens if I move Q? I move Q to be here, right? Then I'm just shifting or moving Q from here to there. So maybe I use different colors so that you will see I'm just moving. I move. So here maybe the red one, moving the Q from this location to this one. Then I keep continue. Then when I make a line connecting those P and Q, you get a line. So I keep continue moving Q until Q, it will be very, very close to A. What do you mean very close to A? For example, here, if you have a B here, this point, what is your B? If I take A, that is your A. If you look to up here, take 1. And here, that is your B. B here is, I'm going to take, if I take A equal 1, if I take A equal 1, then I'm going to consider B. What is your B here? That is a point with Q. Look what you have here. So here, this one here, that is your A. That is our A. And this one here, that is your B. So I'm going to take B as 1.001. So look what you have. If I take A equal 1 and take B equal 1.001 like this, means your Q very, very close to P. Your Q very close to B. When I say very, very close to B, your Q very close to P, right? Your Q very close to B, that is our limit. When you say this word very, very close, means it's a limit. So your Q close to B, which means your B, which this number here, is very close to A. Your B close to A because 1.001 close to A. Then what will happen for this function here? What happened for this, the average rate of change? Because I'm taking A very close, almost B. Almost B. What did you hear me when I say almost B? Means very, very close, means it's a limit. That is when you work in the limit. So what is the average rate of change? Average rate of change, it will be f of B minus f of A over B minus A. What is this one here? That is our average rate of change over the interval A to B. But what is unique about A and B? I'm going to take A and B very, very close to each other. Like, for example, A equal 1, then B 1.001, very close to this. Then because it's very close, then this one I'm going to say limit. Here, this one, instead of every time I have to say, oh, B very, very close to A, I'm going to write limit B close to A like this. But in this case, I'm going to get approximations. Approximation means, you know what is limit means? Limit here, if you recall, when I say limit x close to C, your f of x should be close to a number, say question mark or just a number. So x close to C, your f of x should be close to this question mark. So now what is my average? The whole circle here, that is your average rate of change of your f over the interval A to B. Then it will be close to this one very close to this number, and that is our slope. That is our slope for your f. That is your slope of your f for the entire f, or for your nonlinear functions. This one here, okay, I think I'm just I don't know what happened here. I'm just moving. Looks funny here, but so that is our slope here, guys. That is our slope. I'm just take this one here out. All right, there's not writing here. It's okay. So that is our approximation to our slope. So now, right, so if I have here, all right, so here if I go back to the function here, guys, the function, it is the function here, the mouse is not working here. So all right, so here I'm just looking for the function. Oops. All right, so here I see what happened here. All right, guys, so I'm just, I don't know what happened here. That all right, so here, all right, so here I'm just looking for the sometimes when I do this kind of online here, you will have, you don't know what happened for the function here, for the file is strange, a lot of stuff, no control Okay, so here what I try to say here, I try to look for the graph for the f of x here. It's not moving. All right, so here I'm trying to see my apology here. Okay. Okay, guys, so here we have the slope here, f of b minus f of b. That is our slope here. That is return back to the. So now I need, that is equation number 1 here. That's give us the slope of your f of x. And also I could get another equation here. So how to get the another equation? What happens if I take a here equal, what is the difference between b and a, guys? What is the difference between b and a? Look what you have. Your a here, that is the distance from here to there, that is your a. What is the distance from your b? It's here. So as you can see, if I call the difference between b minus a, I call it h. The distance here, the distance is small here, this small distance here, I call it h. Like after a, you are going to add small b's, which is, I call it h. So what you have here, if I go back here, your b, a plus h, that is your b. For example, here if you have a equal 1, what is your b? It will be 1.001. 1.001 means your b here is a, which is 1, that is your a, plus h, which is 0.001. So that is your a and that is your h. Your h here always something close to 0. So now here, what do you have here, guys? You have b minus a. b minus a. So what is b minus a from this formula? If I take b, a plus h from, look what you have. If you look to the graph here, your a, the distance from here to there, maybe I use different colors. Green, that is your a here, that is your a, right? Then if I use blue, or since I use green here, if I use red here, maybe, so the distance from here to there, that is your b. The distance from here to there, the red one, it's b, that is your b. And then b minus a, you get small b's, maybe I write it yellow or something, that is your yellow here. So that is your h. Your h here, that's the yellow one, because you have a plus little h, right? So if I go back to here, so what do you have? What is your b minus a, guys? What is your b minus a? B minus a here is just h. B minus a, it will be your h, right? So b minus a, it will be your h. Is that make sense here, guys? B minus a is equal h. So now, what is the formula here? Then let me ask you, when b very close to a, when b very close to a, can you tell me what is b minus a? That is your h, close to what? So when I take b close to a, b almost a, so then your h will be close to 0. Right? Your h here is close to 0. Does that make sense? Your h is close to 0. So I'm going to replace, what is b minus a here, guys? It will be h. B minus a, it will be h. F of b, it will be, what is your b? A plus h. A plus h. So, and what is the limit here? The limit, it will be b very close to a means your h is close to 0. So here, the formula, your slope, another formula, it will be limit h is close to 0 instead of b close to a. H close to 0. Here, look what you have. H close, this one here means h close to 0. And then f of b. What is your f of b, guys? What is b minus a? That is your h. B minus a from here, look what you have. B minus a from here, you have h. So if I go back up here, so you will have f of a plus h minus f of a over h, and that is formula number 2. So now that is called the slope. So number 1 and number 2, that is, it will be the slope of your f of x at x equal a. Right? At x equal a, that gives you the slope of your f. F here, it could be linear or it could be non-linear. Number 2, that is also give you the slope of the tangent line, the tangent line, I'm going to explain, tangent line at x equal a. Here, when I go for the graph here, if I go up a little bit, the graph here is the graph. At this point here, maybe I use different colors so that you can see the whole thing. Maybe I use green or so that you can see the whole thing. So here, if I have rulers here and then I connect this one, it's the green one here. So it's a line touch the graph at P. What is your B here? That is where you have A, your B. So you have a line touch touch P or touch at A here, at this point A, you have a line. So the slope of this line, or call it tangent line, that's tangent line. The slope of your tangent line exactly, it will be your slope of your F at A, All right, so that is number, the same definition here. Equation 1 or 2 could be the slope of your f of x at x equal A. Number 2, the slope of your tangent line at x equal A. Number 3 here, we call it the derivative. That is the derivative. I'm going to explain the whole thing. That is the derivative of f of x, if your f of x at x equal A. And here, the derivative of your f of x at x equal A, that's your slope here. But we could write it as a notation like f prime of A, like this. The way that I read this one as f prime at x equal A, that is your derivative of f of x at x. Number 4, and that is, we call it instantaneous rate, all right, instantaneous rate of change, instantaneous rate of change of your f of x, at x equal A, right? So the rate of change over the interval. But here we call it instantaneous rate of change of your f of x at x equal A. The same like derivative of f of x at x equal A, we read it like this, f prime at x equal A. Here we have the slope of the tangent line at x equal A, and here number 1 we have the slope of your f of x at x equal A, the slope of your f of x at x equal A. So equation 1 or 2, that is the one we are going to use it. That is the one we are going to use it. For example here, I gave you one example, then I finish this one. I'm going to give you for each definition 1, 2, 3, 4. I gave you some example. So now, for example here, let me show you. First, let me give you a linear equation. So you have f of x. What is your f of x? 3x plus 1, right? If I ask you find the slope of this f of x, what is the slope? Oh, the slope here is 3. The slope here, I know the slope here is 3, mx plus little b, and here I know 3. Let me show you, let us use equation 1 or equation 2 and show this one, the slope is 3. What is equation 1, the slope? The slope here is limit, equation 2, h close to 0, and that is the one we are going to use. F at, find the slope at x. So here I have to find the slope, right? Find the slope at x equal, say 1, at x equal 1. So I must get x equal A, right? So what is your A, guys? Look what you have, equation number 2. Equation number 2, the slope. Here, I said the slope of f of x at x equal A. So here they must give us A, numbers. So what is your A here for this example here? Oh, for this example here, I have x equal A. What, can you tell me what is your A, guys, here? X at x equal A, it's 1. So you have 1 plus h minus f of 1, that is A plus h, minus f of A, your A here is 1 over h, right? So now I need to figure out what is this one here, and I know the answer should be 3, but let me show you how to use this formula here, because that is kind of general formula to get this one. So now I need to get f of 1, right? What is your f of x here, guys? F of x equals 3x plus 1. Can you tell me what is your f of 1? Replace x by 1. So what do you have? 3 by 1 plus 1. I replace x by 1. What did you get? You get 4. You get 4. What is your f of 1 plus h? F of 1 plus h means you replace x. Replace x here by 1 plus h. If I replace x by 1 plus h, you have 1 plus h. So that is your x. I replace x by 1 plus h. And here you have plus 1. You have 1 plus 1. So just replace x, take x out, and put 1 plus h. Just take x out and put 1 plus h. If I simplify this, what do you have? 3 plus 3h plus 1. If I simplify this, you have 4 plus 3h. 4 plus 3h, right? So now I go, that is my equations. Your slope here is limit, right? I'm not going to take the limit. I leave the limit at the end. F of 1 plus h, from here you have 4 plus 3h. Here minus f of 1. What is the f of 1 from here? Oh, f of 1 is 4. The whole thing over h. The whole thing over h. Look what you have. Negative 4 cancel with 4. it's always like this, guys. What do you have? Minus f of 1. Always the value of f of 1 or f of a, that is called f of 1 or f of a, is going to be cancelled somehow after I simplify. That's always like this. I'm going to show you by more example tomorrow and after the second class. But here, let me finish this problem. So h close to 0. What do you have? 3h divided by h. Can I cancel h over h? Yes, you can. So what do you have? Limit h close to 0. What do you have here? 3. What is the limit of any constant? That's a constant, h close to 0. But what do you have for the constant? It will be 3. And that is we're expecting that because it's a linear equation. So look what you have. 3x. So your slope here is m3. So, but what is the beauty about equation 1 or 2? That is, you can use it for any function I gave you. Exponential, log, nonlinear function, fraction, any function is given to you. It's very easy to get the slope of these functions, or as I'm going to show you here, I give you I'm going to give you more problems for each topic. Slope of your f of x, the slope of the tangent line, the derivative, and that is our entire course definition of the derivative that is come from the limit idea. That is equation number 2. That is f, or you can write it f prime of a. F prime of a, that is limit h close to 0, f a plus h minus f of a over h. All right, guys. I think I will stop here. We continue tomorrow. Next lectures here, I will give you more example about each topic. As I said here, what is in instantaneous rate of change of your f of x, of my f of x at x equal a, what is the derivative, what is the slope. So I will stop here. Thank you.